So we're going to finish up with continuous improvement stuff today. First at the top of the list is the total cost of quality. So there's some things that are the cost of quality. It's basically the cost of poor quality plus the cost of good quality. And poor quality, costs of non-conformers, they're both internal and external costs. And the cost of good quality contains the costs associated with appraisal and prevention, which, okay, I would count those in poor quality because otherwise you wouldn't need them. But a couple of articles if you're interested more. This one just talks about cost of poor quality altogether. It's a few pages long. Kind of gives you a flavor for what they're talking about. And this is on poor quality specifically, how to calculate it, internal and external costs. And then this is a worksheet, which kind of gives you an idea of some of the costs for internal and external, some appraisal costs. And what do we got here? Here's another calculator with some examples. So there's some tools there for you to think about in the cost of quality. It's the whole iceberg thing where the top of it is just the cost of the part, but there's a bunch of costs underneath it when we got a part that doesn't fit or isn't right. So internal costs, scrap, rework, reinspection. External costs, warranty, correction, removal, product liability. Appraisal costs are things like inspection, testing, quality audits. And prevention costs are things like SPC, what we've been studying, quality training, investment in information systems, that type of thing. So here's your total cost of quality. It's divided up between cost of good quality and cost of poor quality. Poor quality has internal and external costs. Good quality has appraisal and prevention costs. Then we're going to move to process improvement metrics. The most common metrics include things like productivity, which is a measure of output to inputs. Higher productivity reflects increased output and decreased inputs. Usually this has to do with labor. So you get more parts with fewer people. Efficiency is a measure of actual inputs compared to a standard output. So standard time it takes would be 3 minutes, but you're under that, so you're more efficient. Standard estimate of what should be produced given a certain level of resources. And then cycle time is a measure of the time elapsed needed to complete the process. When cycle time is reduced, there's typically an increase in performance or increase in productivity and efficiency. And then we've got process improvement methods, some tools and techniques. JIT, just in time, materials are purchased, transported. Objective of JIT is to reduce waste and cycle time. That's just why we do it. One of the things that comes out of JIT is a minimization of inventory levels. Requires smaller lot sizes. So this is a result. This is not a reason we do it. This is the reason we do it. Lean production employs a set of principles and practices that reduce costs through relentless removal of waste. The 7 mudas, or the 7 wastes, and through the simplification of all processes. So it focuses on activities and what the customer was willing to pay for and wants. Connection and flow results in speed and process time reduction. That's lean production. This is the lean process. Specify the value, create a value stream map we looked at, eliminate the waste. At the flow of the customer is make them as the customer wants them and pursuit of perfection. So this is all about a lot size of 1. Six Sigma. Well, we studied this a couple times. It's invented by Motorola in the 1980s. Fact-based process. It uses data systematically to reduce defects. What it's all about is reducing variation among parts. Measures how many defects in a process and works to stop them before they occur. Focuses on fixing the process, not the products. Defect is defined as a non-conformance of quality characteristic, something like strength, width, response time, etc., to its specification. So it's all looking at the spec versus what you produced. And DPMO is defects per million opportunities, stated in opportunities per million units for convenience. So in true Six Sigma, something like a lift axle can have a lot of defects. But in actuality, what we use is NCP tags, and we usually will only put one NCP tag on a lift axle, even though it may have 15 different defects on it. DPMO differs from reporting defective parts per million, which is what we do. Comprehends the possibility that a unit under inspection may be found to have multiple defects, but that's a little bit of extra work that we don't really do. Here's your Six Sigma definition, and this is your 1.5 sigma shift, and this gets into the upper spec limits, lower spec limits. That's what these are. This kind of gives you more about what this 1.5 sigma shift is all about. They're not going to test you on that. And then the inflection points. Six Sigma methodology, DMAIC versus DMADV. So DMAIC, improve existing process incrementally. So it's something, you're making something out on the floor, use this process to improve it systematically. And this is for new processes or improve existing processes more than incrementally. You want big improvements, but usually it's used for new processes. So define project deliverables and customer goals. Those are the same. Measure the process to determine current performance. And here you're measuring it to determine customer needs and specs. Analyze and determine the root cause of any defects. And here you're analyzing process options that will meet the customer needs. Improve the process by eliminating defects. You don't have that here. You have define the process in detail to meet the customer needs, and then control for C and verify down here. Measuring defects, DPMO, 1 million times the number of defects, divided by the number of parts times the number of opportunities per part. PPM, on the other hand, is the number of rechecks divided by the number of receipts times 1 million. So to actually measure the DPMO, you've got to know how many opportunities are there on the lift axle and how many of those opportunities did they mess up. But this is the way we almost always do it. It's just much easier. So this is the 1.5K shift. Usually this is what we look at. If you're up at 2.5, if you're up at a 2 CPK, you don't have to worry about the 1.5 shift because you're covered. 2.33 is 7 sigma, which you don't really see that. These are the number percentage yield here. This is percentage defective. Even at 6 sigma, you got way less than 1%. But you always strive for a CPK of 2. Minimum CPK of 1.33, which is 4 sigma, but still leaves you almost more than half a percentage effective. And then this is the problem-solving processes, how they line up against one another. So PDCA is the plan, do, check, act cycle. 8D, we've studied the 8 disciplines, usually used for corrective action. And then DMAIC for Six Sigma and Kaizen, we use that on our production floors to come up with ideas on how to do something better. So if you line all those up together, plan for the PDCA covers 3 different areas for 8D. Form the team, ID the problem, describe the problem, define and charter for these 2. And then PDCA and DMAIC don't really have something that corresponds with the process walk and contain the problem. But again, we go to define root cause, up to plan again, measure, analyze, ID root cause. And then do, finally, when the PDCA we move, pick a solution, improve, and then check, prevent recurrence, control, and sustain an audit, and then act, congratulate the team, report out. So this is kind of an interesting, these are similar problem-solving processes, but they're not used for the same thing. So this is kind of an everyday thing we use on the plant. This is usually corrective action. This is Six Sigma. And this is an event where we're trying to improve some process in the plant. And supplier workshops. Buyers and their critical suppliers together collaborate on processes to improve opportunities. Usually we do these as CMP workshops where we're trying to get the suppliers to find us cheaper ways to make stuff. Supplier workshops at the teardown center are done though, where we'll bring in the suppliers and tear down a bunch of products. Most of the time, suppliers who are competitors are not in the room at the same time. That's usually a bad idea. And stakeholder feedback, periodically continuous improvement programs should be reviewed by their stakeholders to help determine their effectiveness. Incentives to get the supply base to do this stuff. Recognition, often done through annual meetings. So we do this with our SPM dinners. Rewards, we do send out plaques and letters for SPM, but we also we host a dinner for certain SPM attendees. But we also will go, and most of them are contractual obligation, or we'll hand out new business to suppliers that are giving us lots of good ideas. And in the contract, it's always good to put a CMP paragraph in there, because as they get to make the products, they'll become faster and make them cheaper, and we would like some of that money back. But if they won't give you money, what you can do is say, if your PPM is above 500 or 1,000, you have to put 1% of your sales to us. You have to show that you're investing that in your quality systems. A lot of times suppliers will go for that kind of thing, and which is good, because if you've got a supplier with a lot of problems, that can help. But bear in mind, there are some processes that just are difficult to bring PPM down in. So if you're making an open mold fiberglass hood, it's all done by hand. If you get below 500 PPM, you're doing good. And like I said, on lift axles, you got like 1,500 opportunities for a defect on a lift axle, but still, you want them below 500. All right. Which of the following is the most important element in deploying Six Sigma? I think this is probably kind of one of the ones that's a little bit obvious. Just the way that ISM thinks, I'm guessing it's going to be this one here. I would say reward and recognition is more important, but I'm willing to bet ISM says top management support. Yep. What'd they say about B? B is not correct, because although reward and recognition are important, they're not the drivers of the initiative. I disagree, but okay. What definition best fits a description of a Six Sigma continuous improvement process? Any guesses? How many defects per million is Six Sigma? That's 3.4. Better be A. Yep, A. All right. Questions 8 through 14 are out there. So you guys go ahead and start working them. And if you want, you can do this as homework, this case study. And we'll go over answers at 2:25 unless everybody raises their hand and we get done early. Hmm. Oh, dang, you guys are fast. Okay. Let's go over some answers. Number 8, productivity improvements attribute to all of the following except this is A. Process maintenance is an issue that belongs to production, not to supply management. Kind of a dumb question. 9 is delta. T-test for sample means is a statistical tool, not a process improvement tool. 10 is Charlie. Six Sigma process is used to systematically improve processes by eliminating defects and non-value added activities. Happened to Bravo. Oh, Kettner-Trigo process structured. Okay. 11 is Alpha. Six Sigma's bottom line results, potential impact on annual savings and contribution to operating income. Interest senior management. 12 is also Alpha. Productivity and efficiency and cycle time are the metrics that are most often measured. 13 is Delta. All 3 processes, Kaizen, 8 disciplines, Six Sigma, DMAIC, are all problem-solving processes designed to determine the root cause of too much variation in a manufacturing process. And 14 is Bravo. Lyle is faced with the motivation of his suppliers and needs to show them it does matter whether they provide cost savings ideas. And supplier recognition program is a good step towards that. Any questions? All right. So tomorrow we're going to start on, we get to do section E questions. Okay. See you then.